All right, ladies and gentlemen. So we have just started our new unit on oceans, and we've looked a little bit at the ocean floor, some of the different like formations that we can see on the ocean floor. So things like a mid-ocean ridge or seamounts or the continental shelf or an underwater volcano, things of those sorts. We've also watched a video about how they use sonar to be able to map out the ocean floor because it's not a simple task for us to do. We can't go down underwater easily and see the bottom of the ocean, especially in its very deepest parts. So we're going to kind of move on from the ocean floor today, and we're going to start taking a look at ocean water chemistry. All right, what does ocean water have in it? What is other than H2O, which of course is water? What else is there in the ocean? And of course, the most obvious thing is that ocean water has salt in it, right? It's salty. Hopefully, everybody has had an opportunity. We live in New Hampshire, or maybe Massachusetts or Maine. Certainly, we live in the seacoast region, and so we live near the ocean. So, hopefully, everybody has had an opportunity in their lives, even if you moved here recently, to go down to the ocean and to get experience the saltiness of the ocean. So we had actually talked about this a few days ago or a couple weeks ago when we were talking about the saltiness of the Bellamy River. We also talked about the saltiness of the ocean. We found that the Bellamy was somewhere around 30 grams of salt to every kilogram of ocean water. In other words, 35 parts per or 30 parts per thousand. Ocean water is 35 grams of salt for every kilogram of ocean water. So if you had a kilogram of ocean water and you could break that down into all its different parts, um, then about 35 of those grams would be salt. All right, the rest would be H2O and a lot of other things, but 35 grams would be salt. And so the the word salinity, again, we talked about this when we did our water quality testing, but the word salinity is talking about the total amount of dissolved salts in water. All right, total amount of dissolved salts in water is known as salinity. So there are actually a lot of different kinds of salt. In fact, some of the salts are edible for us as humans. Some definitely are not. They could make us quite sick. And to be perfectly honest, the salt that we eat, if we eat it in too great a quantity, if we have too much salt, that can also make us sick in some ways as well. But it's not exactly considered poisonous, whereas there are some types of salt that are essentially poisonous to us as humans. For instance, the salt that is typically used to melt the ice out on sidewalks or roads or things like that. That particular type of salt is not a salt that we as humans should be eating. However, the salt that's in the ocean actually is the same as the salt that we put on our food. So we typically call it salt or table salt. Its official scientific name is sodium chloride because it is made of sodium and chlorine atoms that are bonded together. And most of the salt in the ocean is this form and its scientific symbol is NaCl, and A for sodium, Cl for chlorine. So sodium chloride is the salt that we eat, and it's also what makes up most of the salt in the ocean. In fact, take a look at this diagram for just a moment. If we look at this on the left here, we have a pie graph, and this pie graph represents seawater, 1 kilogram of seawater. And this 1 kilogram of seawater, most of it is H2O, most of it is water. In fact, 965.6 grams uh, is actually H2O, water. So a kilogram is 1,000 grams. Almost all of it is H2O, but there is a little piece of it 34.4 grams. That is other things, and that's what we call the salinity of the water. And if we actually look at what those other things are, we'll see that most of that is chloride. Another large portion of it is sodium. Why? Because sodium and chloride make up NaCl, or make up the salt that we eat, and so that's what makes up most of this part of the ocean water that is not actually H2O. There are a few other things in very small quantities. There's a little bit of sulfate, there's some magnesium, some bicarbonate, which is kind of like baking soda, actually, similar formula. There's some calcium and some potassium, and then some other things in very, very tiny amounts. So this is what ocean water is made up of. Okay. Couple of things about the salinity. You'll actually find that salinity increases with more evaporation. So the water evaporates. We talked about evaporation when we talked about the water cycle. The water evaporates into the atmosphere, but it leaves the salt behind. And so in places where there's a lot of evaporation happening, the ocean water tends to be saltier. So evaporation happens more quickly the warmer it is. So in those warm tropical climates, you're going to find some pretty salty water, maybe compared to what we have here off the coast of New England. And so I don't know if you have ever thought about this, but when you add salt to water, it actually changes how the water acts a little bit. And one of the most dramatic things that it changes is how water freezes. Normally, water freezes at 32 degrees Fahrenheit, which is the same as 0 degrees Celsius. So 0 degrees Celsius is the freezing point of water. However, um, if you add salt to the water, and it does depend on how much salt is there, but the amount of salt that is in ocean water, it then drops that freezing point to negative 1.9 degrees Celsius. Okay, so instead of water freezing at 0 degrees Celsius, at 0 degrees, it's still just water. It's not freezing. You have to go down another almost 2 degrees 2 degrees Celsius, that is, in order to get to a freezing point where ocean water would start to freeze. And so because of that, ocean water does not freeze easily because of the salt in there. Another reason it doesn't freeze easily is because it's always moving, and moving water is harder to freeze than still water. But definitely a large part of it has to do with the salt. It also has a higher density, and we saw that in the lab that we did the other day. So things float more easily in higher density, on something that has a higher density. So it's easier to float in the ocean than it is in, say, a lake or a river or a stream that does not really have any salinity to it. So if we talk about the Dead Sea, then in the Dead Sea, it's really easy to float because there's so much salt. It is much, much more salty. Instead of 35 grams per kilogram of salt, it's 350 grams per kilogram. So it has a really high percentage of salt and is very dense, and so things float easily because of that density level. And again, we saw it with our lab with the egg. It floated on top of the very, very salty water that we created. All right, here's a picture of somebody floating in the Dead Sea, and also a picture. There's an area in the world where two oceans, one that is much saltier than the other, kind of come together, and they don't mix easily because of their different densities. All right, ladies and gentlemen, hopefully you've had a chance to watch the video about the Dead Sea. And at this point, uh, you should have filled out in your notes the information about salinity in your ocean water chemistry notes. And soon you'll be watching another video that talks about other aspects of ocean water chemistry. I hope you guys have a great day.